giving us, it was able to find my eye. Use the detect smile. That is, if it's smiles. If it's eyes, use the detect eyes. If it's cartoon eyes, use the cartoon eyes image. And I collect a nice image. That is something very basic and something very simple.
Do you want to deploy your web application that you have just created in Python using the Streamlit library? I'm going to show you. So the first thing that you want to do is head over to the GitHub of the Data Professor, and then you want to click on the repositories, and then click on Streamlit 10. And so Streamlit 10 will essentially be the 10th episode of the Streamlit series on this YouTube channel. And so here we're using the sp500-app.py. So I'll provide you the links of the 10th episode in the description of this video tutorial. The rest is Yahoo Finance, data frame data, which will list. I would directly type tip, freeze, and then requirements of the file. And then to copy the requirements.txt, and then you also have the readme. And it would the web. So let me try signing out on the share Streamlit website. Share Streamlit, and so it should be noted.
Opens the desktop, closes it. Ozzy scratches his head.
That for this one, I've signed in using my GitHub. So let me try signing out. And so for the first time when you sign in, it will ask for your authorization that you're allowing Streamlit to have access to your GitHub account. And so I have already done that, so it's going to log in seamlessly. Okay, and so this is the dashboard part of the Share Streamlit website upon logging in. And so I'm going to deploy the first web application here. So I'm going to click on the New App button. All right, and then I'm going to click on the repository. And then I'm going to click on the Data Professor Streamlit 10.
That will be nice. Yes, yes. All through the years, you'll remember that a man went to the gallows because she was too selfish to wait 2 hours.
Boy was
and then the branch will automatically detect to be main, because if I go back to the GitHub here, notice that this says main. Okay, or it could be master depending on your own GitHub profile. All right, and then let's have a look at what is the name of the app, and it's called sp500-app.py. Let's copy that, paste it here, and then that's all we need to do in order to deploy the app. And then you click on the deploy button and then wait for a while. And so if you see this icon coming up, it means that your app is probably going to be successfully deployed. Given that you also have the requirements.txt file that I have mentioned previously. So in just a moment, while it is installing all of the necessary libraries for you. All right, so you see all of the log here. So most of it has met the requirement here, and it has already installed the Wi-Finance library. And it says here that it has processed the dependency, and then you saw the balloons. It means that it had already successfully deployed. And so let me click on this bottom right button in order to minimize it, or I could bring it up again by clicking the manage app and then hide it again. All right, and so congratulations, now you have successfully deployed the web application onto the Streamlit website in the share.streamlit.io. So let's have a look at the plots here. So we see one plot here. If I move to 2, then I'll be seeing 2 plots here. All right, so there you have it. This is the deployed web application, which is quite easy. And it should be noted that currently right now, Streamlit is hosting a beta trial. So it means that you need to be in the 1,000 selected users in order to try out this new feature. So head over to the Streamlit Share website and click on request for invitation so that the Streamlit team will invite you to try out this awesome feature. And so I'll provide you the links to that as well. If you're finding value in this video, please give it a like, subscribe if you haven't yet done so, hit on the notification bell in order to be notified of the next video. And as always, the best way to learn data science is to do data science. And please enjoy the journey. Thank you for watching. Please like, subscribe, and share, and I'll see you in the next one. But in the meantime, please check out these videos. videos.
So today we'll be coming up with a hot topic, face emotion detection. So many of us are like yeah, in we just see the connection for can't do. So filter so now code RTC Streamlit application. Then I loaded my model. This is the emotion dictionary, which consists of classes of emulsifier model, and then tried to detect the face using face cascade. Loaded this one, and here we get this class video transformer. This will help us to like stream the video using Streamlit application. Then here we get the image.
Allow equals set that equal to true. For local use, you don't need to, because it stopped here, the video stopped. I have to rerun it. And what is also cool is instead of using
Have you ever wanted to build a data-driven? Alright, and I'm going to do the same for the volume. Welcome back to the data is 100%. So if we change the input parameters a bit, and we're going to see that now it is still predicted to be Setosa, but the probability of being Setosa is slightly reduced to 90%. And there is a 7% chance of it being a Iris versicolor and a 3% chance of it being a Iris virginica. Okay, and there you have it, a simple iris flower prediction. In this video, and then voila, automatically the model has been built. And you see here that it activates the 1.1 glimpse of the data set. So this is the data frame of the data set. And so here we're using the solubility data set. 1.2 is the dimension of the training and test set, the variable details, and then the model performance for the training set and the test set. So you can see here that both of them are using the build model function to perform the necessary data processing and model building process. And then the results will be printed out directly on the web app. And depending on whether we uploaded the CSV file or not, it will be deciding that based on the condition, if-else conditional statement here. If you're finding value in this video, please give it a thumbs up, subscribe if you haven't yet done so. Hit on the notification bell in order to be notified of the next video. And as always, the best way to learn data science is to do data science. And please enjoy the journey.
tracking dashboard using YOLO-R, Deep Sort, and Streamlit. So if you don't already know, Streamlit is a way to get professional looking web apps or dashboards in which you can interact with your computer vision applications. So over here, what we have is our dashboard. It is detecting many other classes, and currently you can see that it's at a very low frame rate. So what I'm going to do is I'm going to enable GPU right over here, and you can see that it's working much faster. Over here we're tracking the total amount of objects in the scene, and we have the width of our input resolution. We can choose to save the video if we want to. Set the confidence to maybe 1. If we put it at 1, obviously it will be more stricter and won't detect much. If we bring it right down to 0 but not at 0, you can see that it will be very lenient and detect quite a lot of other things. Like in this case, it was detecting a motorcycle for these two signs. And what's really cool about this application is that we can select custom classes. So in this case, we can select a person class, but I want to detect only cars, for example. So I'm going to select cars. You can see in this menu, it's got all of the 80 classes from YOLO R based on the Coco dataset. So if you want to detect bicycles or trucks, for example, you can select buses, and it will detect only the classes that are specified right over here. And what's really cool is that we can import any other video right over here. So what I'm going to do is I'm going to take this sample video, drag and drop it right over here, and it will automatically load our new video. Now it's not detecting anything because we still are filtering by class. So I'm going to change that and change it to person class. So it will only detect people in the image. But say we want to only detect backpacks, for example. So I'm going to go down here, look for handbags. I'm going to take out the person class and maybe add in some backpacks. And this is quite useful in the case for airport security, where you don't want any handbags or luggage being left alone or unattended. So yeah, I really hope you're excited because we're going to be building this dashboard right now. This video is sponsored by Altium, the industry standard and most professional PCB design software on the market. I've used Altium for designing printed circuit boards to build my own custom Arduinos and high-speed on-edge computer vision projects. When I tested other PCB CAD softwares out there, I found that nothing came close to the flexibility, ease of use, and power of Altium Designer. I mean, if you ever worked on PCB design for computer vision applications, you know that transmitting video signals is a very delicate task, with many high-speed signals that you have to consider in terms of electromagnetic noise and crosstalk. Altium helps you to easily manage and route high-speed signals with length tuning to ensure that you receive clear image quality on the other end. What's really great is that we have partnered up with Altium to bring you an exclusive discount for our Augmented Startups community. Sign up with the link down below to get 30% off monthly of the perpetual license of Altium Designer. You can also try out Altium Designer for free for the first 15 days. Just click the link down below to get started. Cool, so if you want to get the code for this, you can head over to the Vision Store at www.augmentedstartups.info/Vision Store, where you'll find a wide variety of projects relating to computer vision and AI. You can explore all of the other projects that we have on the Vision Store. The one that we're looking for right here is called YOLO R Streamlit Dashboard. Now just note that this is a premium lecture, meaning that you'll have to purchase the files in order to tag along with the tutorial. However, if you want to get them cheaper, you can purchase them through the YOLO R course, where you can get all of these projects at a discounted price. So click on here to get into the project. And once you are here, you'll be greeted with this dashboard that says YOLO R Streamlit Dashboard. You can read a little bit about what we're going to do. You can watch a demo of what we will be doing in this lecture, along with all of the requirements, which are a PC or laptop, a webcam, GPU, along with Python Conda. Now all of the files that you need is right over here, so click this to download the files. Now the files that you download over here are exactly the same files that you'll download right over here within the course. So when you're ready, you can either download it here or over here. Let's wait for it to download and we'll get started. Great, so once it has downloaded, make sure that you've extracted it and navigate yourself into this folder. So let's just take a look at the hierarchy. So over here you can see that we've cleaned up quite a bit. So we've got our deep sort PyTorch library. We've also segmented all of the YOLO R and deep sort stuff into one script. If you open it up, you'll see that most of the functions that we use will be right over here for object detection and tracking. The reason for doing this is because our Streamlit file will be nice and clean, and we can focus on only the Streamlit part of it right over here. Other than that, we have our requirements.txt. We also have our sample and test videos that we can try out, as well as our YOLO R pre-trained weights. So if you haven't already, open up Streamlit demo_base.py. So as you can see, we are starting from scratch. There's nothing else inside here. Now before we start, make sure that you have opened up terminal and you have navigated into our Streamlit directory. With that, it's cd for change directory, and then paste your Streamlit directory. Cool, so let's keep this one side for now. And let's start coding our Streamlit user interface for YOLO R. Great, so the first thing that we need to do is to import our YOLO R script that we've created right over here. So we're going to type in from YOLO R import everything. So this will just be a star. Next, we're going to import temp file. We're going to import CV, which is CV2. And then finally, we're going to import Streamlit as st. So the first thing that we need to do, as you remembered in the previous section on Streamlit, we need to first define our main. So main definition is this. Put your colon. And now we start off with our title. So we're going to say st.title, and we're going to name it object tracking dashboard for YOLO R. We're also going to go down and let's write the code that will start up our main script. So that's underscore name equals. This is the main function. Delete that and say try, and we want to implement main. And if that does not work, we put a except system exit. And essentially, we don't want it to do anything, we just want it to exit and not cause any issues. This is so that our app doesn't freeze up our entire computer. Okay, so let's try and see if anything works right off the bat. So right up here, we've got a command that says run streamlit_demo.py. Ours is a bit different, so we're going to say streamlit run streamlit demo_base.py. Let's see what we get. Cool, so as you can see, everything worked fine. Now, instead of just working like this, let's go over to file and open file in project. Save that. Okay, everything looks good here. As you can see, we've imported all our libraries. We've got our main function over here, and the code to execute the main function. Now, let's add in some additional functionality. So we're going to add in a sidebar that will say st.sidebar.title. And this will say settings. We're also going to put in a markdown, like how we did before. st.markdown. We put parentheses over there. Enter. Right over here, we're going to put 3 quotation marks, right? So let's copy this and paste it right here at the bottom again to close it off. We're going to put in our style tag over here. Style. We're going to type in data dash tested, or rather test ID, equals st sidebar. We're going to close off our brackets, open brackets. We're going to put in aria dash expanded equals true. And let's create it in div first child. Open parentheses, and we want to specify our width 400 pixels. Put in a semicolon over there, right? And then we can close off our parentheses here. Cool, so what we're going to do now is that we're going to copy this, paste it over here. Now this will be data test ID equals st sidebar. This will be false. We've got div first child with 400 pixels. And we also want our margin left on the left hand side, and this will be at 400 pixels, or rather minus 400 pixels. And we want to close off our style tag, so just copy that, go over here, press enter, style, and let's close off the tag. Great. Don't forget the comma over here. And then we're going to write unsafe underscore allow underscore HTML equals true, comma. Okay, let's see if this worked. Go back to your dashboard, try refreshing it. And as you can see, we have our settings pane over here. So we can close it if you don't want it, and we can conveniently open it up. So like I mentioned in the previous section, this will give us our margin that's of 400 pixels wide and the width of our main pane. Cool, so let's focus now on the sidebar. We're going to specify our confidence. So this is the confidence that we are going to get for our YOLO R object detector. So we can say confidence is st.sidebar.slider. So we're going to implement a slider for that. So this will say confidence. We can make this capital. And then what we're going to do is we're going to put in the minimum and maximum values. So min-val, or minimum value, equals 0.0. And then we're going to have a max value equals 1.0. We're going to have a default value of 0.25. So let's put in also another small markdown for the sidebar. Sidebar.markdown. And we're going to just put in a divider. So this is about 1, 2, 3 of them. Let's try and run our app again. Refresh. Great, so as you can see, we've got a slider. We can scroll between 0 and 1. So obviously, if it's more towards 0, it'll be more lenient. And if you put it more towards 1, it'll be more strict with regards to the detections. We can even put a markdown up here if we want to. Refresh. I think that looks a little bit more neater, don't you think? Cool, so next we want to put in a couple of checkboxes. So we're going to say save underscore img equals sd.sidebar.checkbox. And this will say save video. We need another one for enabling the GPU. So copy and paste this. And let's call this enable underscore GPU. And this is equal sd.sidebar.checkbox. And we're going to change this to enable GPU. Let's refresh our dashboard again. Okay, so we've got this and that. Right now it doesn't do anything at the moment because we haven't programmed it, but let's gradually get into that. We also want to put in our custom underscore classes. So we're going to specify the variety of classes that we have. And this is on a pre-trained network. So there's approximately around 80 classes if you go into the coco.names file. But obviously if you use your own dataset, it will be different. So this is sd.sidebar. I'm going to put in another checkbox. Let's group these together. And then we're going to say use custom classes. So we're going to save and we're going to put in assigned classes. So that's assigned underscore class underscore ID. This is going to become an empty list. So now that we have our list, right, if we save this and reload. So if we click this, nothing will happen. So this means we need to code in the functionality for custom classes, or rather for filtering custom classes. So we can say if custom classes. So that means if it's selected, then we're going to assign or assign class equals sd.sidebar.multi-select. And we're going to say select the custom classes. Let's just make this a little smaller so we can see the rest. So from here, we're going to have a list of names. And the default name that we want, or the default label, should be person, or the person class. So we can say for each in assigned class, we're going to put assigned underscore class ID dot append. And we're going to append all of the names into this list. This is names.index. Cool. Let's just refresh quickly. If we select this, you can see that we have our classes loaded up and ready. So if you want to, we can select person, we can select airplane, we can select boat. Obviously, it won't do anything right now because we are not tracking anything. So the next thing that we have to do is we need to import our file uploader. So that is video underscore file underscore buffer equals sd.sidebar.file uploader. And this will specify that we need to upload a video. And we want it to be of a specific type. That can be either MP4, MOV, AVI, ASF, and also
Hey friends, welcome to One Little Coder. In this Streamlit tutorial, we're going to learn about Streamlit. Streamlit is a serverless Streamlit. It uses Parallite. I'm not getting into the technical details. But what I'm going to show you is how easily you can build a serverless Streamlit application that can do image blurring. Image blurring, just as an example. A huge shout out to Sushia for this amazing Streamlit library, which is Streamlit. You can. So let's get started with the. So again, please give a shout out. They also have a buy me a coffee page. So if you want to sponsor the tool for Visual Studio Code is edited, the extension itself is about that we can pay with a called root. So you have a script concept inside this setup. So the library is something Parallite supported by Parallite, pure file or files, and then show you what is who are using the we're going to take the features. This is the value that helps rotate increments by 10 input image and then the kernel size, and then we have got the output image. This does not happen. Going forward, we're going to read the image. I'm not getting into the CV details. So we're going to use Streamlit's camera input method. It works. The second thing is NumPy for numerical processing, CV, OpenCV for like computer vision processing, Matplotlib just to display the image, and then we are creating an empty object called bytes data, which is ultimately where we are going to read input data and then store it. Next is we are going to use Streamlit's camera input method, which is going to help us to take the picture. So the picture that we took is using camera input. After that, we are going to take the picture value and then store it inside bytes data. Just a validation step. We are going to check whether bytes data is available. If bytes data is none, which means something has gone wrong. Maybe you have an image upload feature, image has not been properly uploaded, then we are going to stop the application. Let us say that did not happen. Going forward, we are going to read the image. I'm not getting into the CV details. We are going to read the image, display the size of the image, then we are going to say that we are going to transform the image, and this is where we have got the kernel slider. So kernel size is the value that helps us control the intensity, the blurriness of the blurring that we want to do. And you can see that we have a slider, Streamlit slider, where we have values from 1 to 10 increments by 10, and then we can see case size is an object where we capture the value. The next thing is we want to blur CV2.blur, as simple as that, input image and then the kernel size, and then we have got the output image. Now the output image is like initially you can see that we decoded it. Now we have to further encode it in .png format, and the encoded data is stored here, and then finally you can display the image even without Matplotlib. Fit it inside root, JavaScript module, open it for the first time. Once this is loaded, picture. This is different, not smiling. That's okay. Anyways, let me smile. Take a picture, and then you change the kernel. So you can see you're changing the value. You can go from nothing to completely blurred. So you can do it, and then click the download, and then it's going to save the image for you. That's it. As simple as that. As cool as
example would be, I would say we're not strong enough to take on Microsoft, and they wanted to do an operating system and a
Hey everyone, welcome to my channel. In this video, we are going to learn how to create real-time face attended system that is linked to a real-time database. You can see at the back end, this is our real-time database. It has all the information already marked. So after an X amount of time, you can mark it again. We will create more than 30 web apps to create these amazing projects. So here you can see it is a little bit laggy because the graph starts yourself with a wide range of code as that course system that can be used for schools, for employees, CVs, or CVs. So in the face recognition, wrong. No, let's delete all of them, and we are manually going to write the code. So our server in the database into, and then extract, and then we will put it on the image background. Okay. And we can mark others as well. So if I wanted to mark, I can mark, for example, let's say I want to mark Elon Musk, and I will go here, and there you go, loading, and it shows Elon Musk. So that's the idea, it's marked. And now I will do for Emily Blunt. There you go. Emily Blunt detected, major economics, total attendance, whatever the attendance number was. So that's the main idea. So this was our complete project. Everything is updating, everything is running fine. So if you want to learn more about this, if you want to learn how to actually implement this on a website and how to actually use it in real time, you
In Shawinigan, at a processing facility for critical minerals used in clean tech like electric vehicle batteries. At a manufacturing plant where they're making hybrids, but where they'll soon be making fully electric vehicles too. At a factory where they make electric vehicle charging stations. The world is moving towards zero-emission vehicles like electric cars, delivery vans, and buses. That's why we're building up a supply chain that goes from the development of critical minerals to the